Matt, take it away.
All right, thank you very much. So, this story today starts in 1979. Who was born in 1979? Can I see some hands? Nobody? Wow, that's pretty sad. Alive. Okay, good. All right, so this British gentleman, Dr. Christopher Evans, in 1979 released this book called The Mighty Micro, which I heard is amazing. I never read it. I'll be very honest with you. But in this book, is talking about the future of computers and how microcomputers, which is like big computers for us now, but at the time was microcomputers, will really change everything, and they will affect the economy, the industry, and the lifestyle. And that book was released in England first, and then the rest of the world. But when it was released in the UK, people kind of freaked out. They're like, this is amazing. And at the time, people cared about the future way more than now. And ITV, which is one of the channels in the UK, created a documentary talking about that book and talking about computers and the future of computers and like everything we'll do. They had no clue about internet, but they talked about the future. And the BBC thought about that, and they're like, well, we really like it. We want to do the same thing. And then they released this series on how to teach computers to kids.
Minimum iron, that's half a spin symbol, and program E. There we are. Now, if you've used a modern washing machine, you'll know what a program is. The program consists of a preset sequence of jobs. Water in, powder in, wash, rinse, spin, and so on. You don't need to worry about it. Now, the steps a computer goes through may seem a lot more mysterious, but it's still a matter of just one thing after another.
So, you need to enjoy I'm leaving the credits just so you can enjoy it, because this is learning, education coming to you, the knowledge is coming to you in your house. And special graphic effects. So this series started in 1981, 82 in England, and then they were really trying to teach programming to kids and to grown-ups too. And this is just another snippet.
The word program is a well-chosen one for computers. I mean, there's nothing new about the word. What it usually means is an ordered series of events at anything from an orchestral concert to a village festival. Now, to use the word for a series of instructions isn't a very big jump. But when we talk about programming computers, the word suddenly seems to take on a rather different meaning. I mean, if you think about a concert program, the list is just made up of pieces of music to play. And what you won't see is that after the interval, the London Philharmonic Orchestra will hold a bout of all-in wrestling. And even by changing the instructions, a motor car assembly line won't suddenly start turning out pottery. But a computer seems to be able to do just about anything. I mean, it can play music. It'll give you your own personal telephone directory if you wanted to. It can even draw pictures.
So for this series, they needed to have a way of teaching. They wanted to teach people, everybody, how to use a computer, but they didn't really have a computer at the time to really teach things. So they, that's the BBC, so it's a part of the government, and then they decided to do a bid so someone will come and design a computer that they would use with the video program to teach people. And Acorn was a British company who later on became the company who created ARM, which is a microchip set. Designed this computer, won the bid, and they actually used that to design the ARM microprocessor. But what's interesting is that if you think about this video, they have these big computers in the back, and this is like late 70s, early 80s. People don't really know what computers are, and you need to teach people how you're going to become a programmer. And when you watch those videos, and they're all online on YouTube, it's amazing to understand that it's actually easier to listen to this guy understand and hear about programming than it is now when you go to a talk and they tell you all about Swift and Kotlin and all these different things. Here, it's just saying like, it's like your dishwasher or your machine washing, and just like those simple things. And they wanted to make it fun. So the first thing they show you is like music and pictures. It's not like, let's make money. It's like, you can create graphics and you can do all those different things. And I think that was really inspiring. And at the time, the British government ended up buying a lot of those computers to put them in schools. And in 1982, they had this BBC Micro, so that's the computer that Acorn built for the British government, and then they sold them across Europe and then in the US a little bit. This computer was 2 megahertz CPU, so this is like really not much. However, it was really fun computer at the time, and an entire generation of kids and musicians also, since I'm in the world of music, really learned programming and sequencing and doing a lot of cool stuff by using those computers. And I think there was this desire of thinking about I can create video games, and video games were much easier to write at the time. So this passion really inspired an entire generation. And 30 years later, they came back with a new project.
The MicroBit is a pocket-sized computer that lets you get creative with digital technology. You can code, customize, and control your MicroBit from anywhere. Light up the LED display to create something simple in minutes, or even communicate between microbits. Or get really creative with MicroBit's more advanced features, like its buttons, motion detector, compass, and sensors. You could create a guitar that changes the volume the more you shake it. Or a flick football game that powers a MicroBit scoreboard. And you can connect it to other devices, sensors, and everyday objects. So you could water your thirsty plants, or use Bluetooth to take photos with your phone, and control your music player. And you can customize the MicroBit in any way you can imagine. It's really anything you want it to be.
I think it's a bit like a robot.
It's quite different to any other technology I've sort of used before.
You just have fun with it.
I can control my tablet. You can make games, you can take pictures.
Kind of something that senses movement, and you can just place it in your pocket and make whatever you want.
We'll describe it as a future.
So as you can see, in 30 years, we learn better how to communicate with kids, and the society has changed. This video is way more entertaining, but the first one was also interesting how they still had the same interest in making something fun and educational, not just like learn the knowledge of science behind it. So they came up with this MicroBit, and the MicroBit, I have one here. I'll let you play with it later on. This is a small device that was designed for kids to learn how to write program, but also for grown-ups how to play with it. So it's not just a limited things for kids. The specs, it's a 16 megahertz, so it's 16 times more powerful than the original one. It was designed, the CPU was designed by ARM. It's actually a microcontroller with 256 kilobyte of flash memory, which really is not much, but it's plenty enough to do basic programming. Now, what's really interesting about this board is that it has USB 2, but also BLE, an accelerometer, so you can basically understand, it's like your iPhone, when you move it, you can see if there's movement or not. Magnetometer, which lets you know, you can create a compass with it, or you can detect if metal is coming by. You have 25 LEDs, so these are the little lights, and you can program them and you can create a really nice cool display with that. You have 2 buttons that you can program. You have a reset button in the back, and here you have a bunch of connectors, and we'll see what we can do with them. But it's basically kind of a card connector, so you can plug it in, and you can have 25 or 27 other connectors that come out to do a bunch of advanced things. And you have big holes, so you can take those 5 holes and put clips on them, and I'll show you that later on. But you can basically connect something like this into it, and we'll put a speaker on it and see what it does. But it was really designed for kids to have fun in class, kids who don't know anything about programming and just get started. And the idea is like we're going to inspire an entire generation. Now, it also comes with an external battery, or you can charge it by USB, but the cool thing is now it's really portable and you can take it around. Every kid in Britain in grade 7, so age 11 to 12, is getting one of those for free at school, which is really amazing. That was released about last year, a bit before for some from schools. I got lucky. I have a friend who actually got me one at the time, and this is my daughter and I working on a project. So she wanted to program it, so we were talking about it, and she started drawing what she wanted to do and how it would work when you press the button. We were talking about like what is a loop and everything else. And I recorded a quick video of her explaining what she's doing. It's in Spanish.
Mi nombre es Gianna Aimonetti. Este es mi robot que se llama MicroBit.
If you don't speak Spanish, just pretend you understand. You probably should learn Spanish. It's an important language.
Y ahora voy a hacer una presentación de lo que voy
So she programmed it.
mi MicroBit.
So she programmed it, and she's showing how she designed it. So when she presses the buttons, it will do different things.
Lo aprieto.
So when she presses
hace
the
una
button,
línea, una flechita.
it shows an arrow.
Si
Shows an arrow to the right.
lo pongo en A,
If she presses the other button,
hace
she
un
gets a little heart.
corazón. Si hago los dos,
She presses both of them,
hace mi nombre.
it spells her name.
Pero si lo
And then if
hago
you shake
así,
it, because of the accelerometer,
así lo hace
it does a
como
random pattern
todos.
until it fills up the screen.
Ciao, ciao. Du, 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 du.
So that's my 7-year-old programming robots, and she loved playing with that because she could see the results right away. And I want to show you her code. So this is a screenshot, but I'll just go to the page itself, if I can. Here. So this is how she did it. So we went onto the browser. She has I think we use my computer, but she could have done it on the Chromebook she has, and it's all all done using blocks. And this logic blocks, we spend a lot of time talking about them, but you don't need to know how to program as much as understand the logic. So you can click on input and you say when the button A is pressed, and you can choose the button here. It's a bit small, but you can see, you can decide what you do. When you have a bunch of blocks, you bring it and you can clip together. So let me just remove this one and show you her logic. So this is her A button. So she said, I helped her with the looping part. So just ignore the second value. That's for another advanced features. But here we say, when button A is pressed, show this image. And she drew in the UI the little heart at offset 0 and also play a sound. Now the problem is I have the device here. So I just want to show you how it works. This is empty. Once we were finishing, as we were debugging, the way we were doing it is we were just plugging it into the computer. So you plug the USB device, take the USB, you don't need the battery for that. You plug USB into the computer, and then you just say download. What's funny is the device shows up automatically on my sidebar here as an external hard drive, and I can take the binary file, which is a firmware that I just downloaded from the web, and I drop it onto the device. And then it will just flash, it will copy it, or at least it should. Yeah, it copies it, it unmounts the device, and now I can use the power of the USB, but just to show you I'm not cheating, I'll take the battery pack, plug it in. I can show you in front of the camera so it's easier to see. I press, sorry, making a mess. Let's start again. I show it to you in the front of the camera, pressing the button A, I get the little heart, the B, I get the arrow, the two buttons, I get her name being spelled, Gianna, and then if I shake it, I get this random thing. So that's really her program, the program she wrote that I can run on my device. She can share that with friends. She could do way more. But as you saw, we had this interactive interface here where we program, but what I didn't show you is that we actually debugged first on the web. You can actually press and you can see the logic here. And check, and you see that. So she was able to really do it, and the UI shows us how we should be plugging in our speakers. So we didn't use the mini jack, we did a slightly different version of it, but I have a speaker here, that's a little bit speaker, and I have some crocodile or alligator, sorry, and I plug them in, and I'm going to be plugging in the ground like on the UI, in the UI. So I just go in the other side. It's not going to be super loud, but so you can hear So there's a button. And then what I didn't show you is when we press both buttons, you should get so, you know, when you're a 7-year-old and you see your dad coding all day, it's kind of a big deal to be able to code on hardware on top of that. And I think that really made a big difference in our life because now we get to code together. She's not like, Daddy, stop coding. She's like, Daddy, let's code a robot together. So that's a lot of fun. Also, what I didn't show you is you can convert the blocks into JavaScript. So the same code, you just toggle the tab, and it shows you the exact same code we wrote, but in JavaScript. And you can modify one or the other, it converts. So it's a very good way of teaching kids once they get to a certain age, like, well, actually, what we did as a block, here's how it looks visually in the code, and then you can take them further and write more. As I showed on Mac or Windows, as soon as you plug it in, it shows up as a hard drive. You just need to drag and drop the file in it. That was the demo. Now, what's even better for a lot of kids is you can just use a mobile device. So not everybody has a computer at home, but most families have at least a phone or a tablet. So you can do exactly the same thing on your tablet. And what I didn't also say is that the BBC actually didn't spend that much money on this project. It's a lot of different companies who came together and sponsored the project. So ARM did the microprocessor, there's another company who did the PCB, the board, Samsung wrote a bunch of the software, Microsoft did the UI with all those different things. So it ends up being pretty cheap, and that's how we can get it for $14. It's also, well, I spoiled it, but yeah, in the US it's available for $14. You can also build it yourself if you wanted to, it's all open source. And it's not just for kids. So let me just stand it around so you guys can play with it. I might want to reset it. No, press button. So it's not just for kids. So I show you the JavaScript block editor. You can write it in JavaScript directly. You also have a Python editor, which is really, really powerful. What's cool with Python, even though I'm not a big fan of the language itself, they did an amazing job at creating this embedded Python. And the way it works is like you compile your Python and it runs on this tiny little board and evaluate the Python code in runtime, which is really cool. And then there's also Go support. So I'm a Gopher, so I write a lot of Go. And I'll show you how you can run Go, not quite on the device, but using BLE. So you can buy it in the US, it's $16.50 for the entire kit with the battery and everything else. The board itself is only $14. I think you have no excuse not to buy one for Christmas for your friends, your cousins, your nephews, your dad, your mom, your grandparents. It's really straightforward. If you have a laptop or if you have a phone at home, you can play with it. And for GoBot, the way it works, I'm running a bit low on time, but the way it works is there's full support in it. But instead of running your code and pushing your code onto the device like I did with the binary file, what you use is you use BLE, so Bluetooth Low Energy. And the way it works is your computer can communicate, or your device, whatever you use, can communicate directly with the MicroBit and make it do whatever you want. So I had an example, but I will need the MicroBit back. Do you guys want to see it, or you? Yeah, you want to see it? Okay. So this is the entire line of code, the entire code. So for that, I need to flash the firmware. So the same way I did it earlier with my daughter's program, I'm going to reflash it, and I'm going to be pushing a firmware that removes really the security, because BLE is secured with crypto and a pin that changes every single time. And for the demo to be easier, I'm just going to flash it right here. So I'm just flashing it so I can remove the protection on it, and I can connect directly from my laptop. Okay, so I flash it. Here it's telling me, I can show you on the screen. So what it wants to do now is recalibrate it. So I need to rotate, and I need to draw this. Well, let's see if I can do it. I need to draw a circle to recalibrate the accelerometer. Of course, I'm not good at it. Usually I get my daughter to do that, so. Okay, so I have my pattern. I should be able to turn it off. Turn it back on. And that didn't work. Great. I need to do it again. I need to draw a circle. No, it's with this specific firmware. Okay, now I got a smile. I did it right. So now it's set up. I can show it. And I'll go through the code very quickly since it's just a few lines of code. I'm trying to, yeah. Okay, so for those who don't know Go, this is just at the beginning. Let's import all the libraries we need so we can call them directly. Then we have a main functions. That's the entry point. That's the code that gets executed. And here we're saying load the BLE adapter and use the argument that's being passed. And I'm going to give you the name of the BLE ID, which is basically the name MicroBit and the name of the device. Then I tell it, okay, we're going to use the LED driver. So we're going to use this driver, the driver for this, on the BLE adapter. And when I will ask you to work, this is the function you're going to be executing. You're going to be clearing the screen, and then you're going to wait 1 second and execute this other function and write hello Santa Monica. Then we define the robot, which is the way GoBot works. Like, okay, we want a robot called BlinkBot, and we're using the BLE adapter. We're using the MicroBit device, and then this is the function to execute, and then we start our robot. So let's see. Let's go back to the terminal. I'm going to be running this program, making the font bigger. Not that you need to see too much of that, but okay, it's connecting, and it should be connecting via BLE and start hello Santa Monica. So you can see GoBot has adapters for any of the components on the board, so you can make it work from your cell phone or from your computer, and you can talk directly to it. It doesn't have to be connected to the computer. I'm only using that for the power. I could have switched back to the power supply. But you can do way more advanced things with that. So Go is probably more for people who are already programmers and they want to do fun stuff. They want to automate things. You can get the temperature at home, for instance, and use the GPIO to switch your thermostat. Do something like you can build your own Nest with that. And this is it for the MicroBit. I just wanted to share other resources for kids and for beginners. What I'm hearing a lot when I present those things is like, this is awesome, but I have this cousin, and she's 35, and she wants to learn how to program, and I don't really know where to start. And funny enough, a lot of the stuff for kids, also are good for grown-ups, but it's not always easy to know where to start, and it's also, you don't want to be like, oh, I'm not a programmer, how do I teach kids how to program? Well, my recommendation is to start by a game. There's this game called Lightbot. It's free on Android and iOS. You have 2 different levels. I recommend you start by age 4 to 8, even though you're a grown-up. And what's really nice with this project is the way it works is you're this little robot, and you start at a certain point, and you need to go to a blue check, and you need to turn on your light on your head. But it's not a game where you play in advance, and you just say, you don't play in real time. You need to enter the programming steps ahead of time. So here you say, okay, this is my program. I want you to go straight, turn right, turn left, and then turn on your bulb. And what's interesting with that is that it really teaches kids to understand, or even grown-ups, understand that programming is a series of comments you do in advance, and then they go further where they start allocating that into a loop, or you can do a program, and then you trigger this function. And it's really the most amazing way I found, at least with my daughter, to teach her the concepts of programming, loops and conditions. And this is a game that really is a good starting point. You can also play. It's a bit more advanced. My daughter being 7, the more advanced one on Mac and Windows was a bit too complicated. We started with this one. She's almost done with it now, and she's moving on to the other one. But you have a lot of things that you don't really think about when you've been programming a long time. But when you ask the little bot to move, and you tell them, okay, I want you to turn left. left here would be left here, and for a kid it's not always obvious because they don't see it from the perspective of the robot. And you have a lot of those discussions, and when you start talking about debugging, that's super useful. The other one that's really amazing, it's in Spanish on this page, but it's also in English. It's Hour of Code. We spend a lot of time with my daughter doing that. She has a Chromebook, and you can do it on the web. They have a lot of really cool games, Minecraft and Moana, and of course Frozen. So this is the same concept of blocks, but they have more of a mission. So they tell them, okay, you're Elsa, and this is the first step. You need to move forward 100 pixels. So you have discussions about what's moving 100 pixels, about directions, and then you just drag and drop the blocks into the comments, and then you make it do the different steps, and it gets more and more complex over time. And it's really an amazing way to teach programming. That's it. So, any questions? Oh, you can clap. I like that. Thank you. Any questions? Yes. Wait. Okay, yeah, I can repeat the question. The question is, how come the Go code doesn't run on the MicroBit? The MicroBit is 16 megahertz, so it would be really hard for it to run on 16 megahertz and 256K of RAM. So basically, the runtime of Go will not run on that. Well, Python has a trick. They basically have their own fake runtime that's on it, and it's not full Python. So they basically compile into assembly code, but they have a way of tricking. I'll send you the article. It's actually fascinating. They have this embedded Python approach that runs on that speed. Yeah. That said, I don't know exactly the details. So, but yeah.
Yeah. What's the earliest you would start with the MicroBit?
I would start with the little bits. So we have those guys. I showed them probably a couple of years ago now, but it's the same concept, but it's hardware, and you just use magnets to put them together to start with a signal. With the MicroBit, I started with playing with my son, who's 3 years old, or he's going to be 3. And what we do is my daughter writes the code, or I write the code, and he plays with it, and just interacting with the buttons. And I tell him, like, what do you want it to do? And he's like, I want to make a face. So you get them as PMs, and you're like, okay, you're the project manager, and you make them play with that. But I think around 5 is when it gets fun. I would do Hour of Code first, and show them, like, let them move Elsa, or let them work with Minecraft, and they do some of the small things. And be like, hey, you can use that to actually control hardware, and that's when you bring the hardware. That's my suggestion. And then it depends on the kids. Some kids just don't connect as much. So what's nice with the little bits is you can also connect with Legos. And something with the MicroBit, you can use a little motor and make something move, and also then it's a lot of fun. So. Any other questions? All right, thank you very much. Oh, actually, I wanted to show one more thing. I forgot. Yeah, this is going to be more interesting than the keynote yesterday, the Apple keynote. So that's another little device. This is another thing you can buy. It's not really expensive. It's called Makey. And what it is I know a bunch of people in the office are like super fancy with their keyboards and all the keys. This is a keyboard. So this is a keyboard. The difference is that you need to plug in those things, and then you trigger them by creating a contact. So what's really fun is you can say, I'm going to use the mouse click. So this is the mouse click here, and this is the ground. And when I'm touching two things, it's going to trigger the mouse click, right? So that goes into USB onto your computer. And what you can do with that is you can plug that into a banana, for instance, or an apple, and whenever you touch the banana, it will trigger the click. So now you can create something where you have like a keyboard for music that gets triggered on your computer using small things like that. And I can tell you, kids love that. Another fun little trick to do is you can use those metallic stickers, and you can create circuits and just add LEDs and get kids to click on them and get the power to go through. Another thing I use with my kids is this electric paint. So this is just like a marker, but you can actually create a circuit. So my daughter loves drawing, so she would do like complex drawings, and then on the back we create a circuit for it, and then we put the power on one side and like LEDs in the eyes or something like that, and she can just trigger them by plugging in or pressing a button. So those are small things you can do with kids that they just have a lot of fun, and as a grown-up you'll have a lot of fun too. Thank you.